All right, so this is finishing up the 7A1 notes. I'm just going to go through the rest of that Kahoot right here. So let's look at this. We did number 1 in class together, so let's look at number 2. It says complete then use the table below for West Nile virus test. Now we're going to need to talk about what this is. Negative predictive value means how accurately is the test giving people negative results. This means we're giving people a true negative. So if you're doing a negative or a positive predictive value, you're actually looking for the accuracy of the test. So we're going to look at all negative tests and we're going to put the true negatives on top instead of doing the false negatives, okay? So this is just slightly different than false negative because we're saying these people were correctly identified as having a negative test result, which means they did not have the disease. So it says this means a true negative. Out of those that test negative, what is the probability they are not infected? And we're going to round our answer to 4 decimal places. So we do need to fill in the rest of this table. This adds to 19, so that would have to be 17. 17 plus 6 is 23. We've got some big numbers here. Let me pull up my calculator. We've got this 677 minus the 23. That would be 654 would be the total of people who were not infected. Notice those add to now 677. We have 2 people who positive test results, so that means 652 of them were negative test results. And if we add this column together, we get 658. So, all right, so if we're looking for the negative predictive value, that means out of all the negatives, so we're kind of conditionally doing just negative test results. So notice this time it's a column instead of a row. So you still focus on negative test results. We're looking for people who tested negative correctly, true negatives, which means they are not infected with the West Nile virus. So if you look at the group we're in, there's 658 negative tests total. And if you test negative, but you're sick, that means that's a false negative. That means we told you you're fine, your blood work came back fine, but you actually have the West Nile virus. The people who tested negative and did not have West Nile virus, they're not infected, they were the ones who were correctly identified by that negative test result. Okay, so if we divide that, 652 divided by 658, you'll see that the accuracy of this test is 0.9909. So it's like a 99% accuracy. That means this test has been validated as a good one to give people because it's going to catch 99% of the people who do not have West Nile virus. It's going to correctly identify them almost 100% of the time, but it's like 99% of the time, okay? And like I said, they usually want that a small like margin of error for that. So under 2% error is usually a good result. Okay. All right. So now we're going to do a question together. So I'm going to do it as me, essentially. I don't think it's going to let me choose since I'm not doing practice mode, but let's just work through it. So we've got this table already filled out and it says urgent care clinic wants to determine if a new brand of test is effective in determining whether or not a patient has anemia. Use the table to find a false positive. So remember, false positive is out of all the positive test results, we're looking for people who were incorrectly marked as positive, which means it told them they were sick, but they're not. So we're going to hyper focus on the people who got positive test results, which is this row right here. There were 93 of them. And the people who were incorrectly identified, because remember, positive test means you should have disease. There were 2 people who they said you are sick, but their body is actually not. So 2 out of 93. Now, I don't think it's going to let me choose it since, like I said, I'm doing it as myself, but it is 2 out of 93. Let's see what happens when we skip. Yeah, it told me it was the 2 out of 93. So that was the correct answer. All right, let's go to our next slide. Because like I said, I just wanted to finish up this 7A material. And it's counting you guys, even though you're not here, sorry. So now we have number 4. An oncologist wants to determine if a new brand of test is effective in detecting whether or not a patient has cancer. Use the table below to determine the test gives a false positive or a false negative. So notice we're combining the false positive fraction and the false negative fraction, doing an or problem. So hint, find the probability of all the false positives that could happen, plus probability of false negatives, and sum them. They're not going to be anything that overlaps, so we're not going to have any subtraction. Getting a positive test is completely separate from getting a negative test result. So they're mutually exclusive from each other. Again, if you're doing two rows or two columns and you're comparing them, you're not overlapping at all. So we're going to look at the false positives first, then we'll look at the false negatives. Okay. So I'm going to write down my fraction for probability of false positives. Remember, that's all positive test results and then the ones that were incorrectly marked as positive. So there were 135 false positives, or not false positives, sorry, positive test results. And positive means you should have disease. So there were 22 people who were actually not sick. Incorrectly had a positive test result. Their body is not sick. Then we have the probability of the false negatives. So that's going to be all those negative, false negatives. I need to write it correctly, over all negatives. Okay, so all negatives is 105. Again, a totally separate group from the 135. And then remember, negative means you're not sick. So these 98 people were correctly identified. They said you're not sick, you had a negative test result, and they're not sick. It was 7 people who were incorrectly marked as you are fine because they got a negative test result, but they're actually sick. Now, the only problem with this one is this: when you go to do the OR, you've got two fractions that don't have a common denominator. So you will definitely want to use your calculator for this, because this is 22 over 135 plus 7 over 105. And they do want it as a simplified fraction. So I'm not sure if I can do this on the calculator. I know I can't do it on this calculator, but I can try and find a common denominator. 135 times 2. I'm just checking to see if any of these are divisible. Is that divisible by 105? Nope. Because I could do times each other, but that's going to make it really big. Nope. There we go. So they both go into 945. So, and I was just trying different things. So this one, I believe I had to times it by 7. I'll double check that. You want to use your calculator. And this one, I have to times it by 9. So let's double check that that works. So this is 135 times 7 is 945. That's my denominator that I came up with. And 22 times 7 is 154. And then 105 times 9, we want to double check that that's also 945 so that they get the common denominator. That's 945. And 7 times 9 is 63. So we're going to add our numerators. I can't talk. Add our numerators together now that we have a common denominator. That's 217 over 945. And I don't have the ability to reduce on this, but I don't think that does reduce. But you have to double check on your calculator. So that is how you do an OR. You find each probability, since they're not overlapping, separately, and we just add them together. We did not have any groups of people who were in both of those countings, okay? And then that is it for 7A1. So I knew it wasn't too many slides. So when we get back into class on Wednesday, we will start with 7A2. So we're going to be talking about histograms and shapes of those. Okay, I'll see you guys on Wednesday.